if you have any uncertainties of how it was done, let's say that you're more of the observer today than the doer on the laptop, then you'll have this step-by-step available as a recording posted on YouTube. All right. So we're going to do a new project, and we want to make sure that we're in SI units. That's one of the first things, just to refresh our memory on the workflow when we're doing WaterGEMS. Tools, options, make sure that the units are in SI and not in US customary. If it's in US customary, then switch it to SI, click OK, and if you made a change, you're going to have to start the program over again to make sure that it loads in from the beginning in SI. Mine was already in SI, so I'm not going to start the program over again. All right. Down here, background layers on the screen, right-click. We're going to add a new background layer, and it's going to be a file. It's going to be that file that I've just emailed to you. I'm going to have to go get that file from my own computer.
What units SI?
Yeah. Okay, so here's that map file that I sent to everybody. It's what it should look like. So what I want to do in WaterGEMS, right-click on background layers, new, file, and then browse to the location of that image. There it is. So then you get some sort of a dialog box here, and it's wanting to know what scale to import that at. It's wanting to know how many pixels is how many meters. What's the relationship between distance and image size? I've already scaled the image so that 1 pixel will equal 1 meter, and we're not going to have to enter anything in. No, there's just one file. It should be the same image file. Everyone will have the same.
Do we need to change the unit meter?
No, you don't need to change anything. Just click OK. And then there's a button here that zooms to the extents. Okay, with that, we're going to set the computers aside for a moment. I'm going to hand out this piece of paper, and I'll circulate around. If you do have a computer problem, we can talk about it as you're focusing more on this paper. This is a network that shows a small community, and there's a basic pipe network that we're going to try and analyze. You go through the steps of prepare, which you have to write down the elevation of the junctions that are noted, and this is a contour map, and so you estimate the elevation to the nearest meter based on the contours. Create, we've added the image in the background, and then you're going to draw a network on top of the image file there. And then we're going to do some simulation. And so for the first thing, let me hand this out. And what you need to do is write down the elevations. And then we'll actually skip over to demand estimation just briefly. Demand estimation is inside of the network. There's some residential areas and some commercial areas. And in the small residential blocks, it says that they're requiring, I think, is it 8? Go ahead. All right, so the first thing is elevations. Determine the elevation for each of those junctions in the network by using the contours that are provided to the nearest meter. Are there any extras of that map? All right, so write down the elevations. Look at each of those junctions, figure out what's the elevation. And then after that, skip over here to where it says demand estimation. What we're going to try and do is find out how much water is coming from a couple of these arrows. Up on the map, there's 2 green arrows that's feeding water to the interior parts of the city. If we zoom in on the city itself, water goes into the city here, that green arrow, and this green arrow. And so all of the water that's needed in the city is split evenly between a demand here and a demand there. So you have to find out, based on the information I give you here about commercial, large, and small residential blocks, how much water is needed inside there. So count the number of blocks, multiply it by the demand. It's very easy. Elevations. We're getting elevations. We're not playing with the computer. We're getting elevations.
Go to this visualization.
No.
Oh, you want us to write on this? Okay.
Yeah. You can write it right on the paper there. That's going to be your paper to keep. And then start doing the math of how much water is demanded in there. Yeah, go ahead and write on the paper. We know how big the pipes are. That information is given here. We know the pipe sizes. We know their location because we're going to draw right on top of the map. And so the next step is to create. We're going to draw the network. Now remember, the tool for drawing is this one right here, pipe. And so I'm just going to draw. I'm going to drop a junction right on top of where it's located on the screen. So here, click again there, B, click again here at C, going down, clicking, and I'm being as careful as possible because it's getting the lengths from where I click on the screen. This is a scaled drawing. And click again. Zoom out. Well, escape. Pan over. And then I want to draw a line over here to my reservoir. From junction, right click, reservoir, the end. So if I turn off the map from the background, there's my network. You can toggle it on and off so many times. So draw your network. Make sure that the reservoir is not a junction with a reservoir. If it's a junction, you can click on the reservoir symbol and drop the reservoir on top of a junction that will change it. Let's say that up here in the corner, I had a junction instead of reservoir, and I wanted to change it. All you got to do is click on the reservoir symbol, and then click on top of a junction, and it'll change it from a junction to a reservoir if you had put a junction at that reservoir spot. If you zoom in, it actually has labels on these. It's just that they're so small right now. Let me zoom in and show you. Oh, there's these little, tiny little labels. They're not big enough. And you may remember we've talked about this before, how you can change the label size. I'm going to go into Tools, Options, Drawing, and I want my symbol sizes and text to be larger than they are right now. Maybe I'll do a multiplier of 9. Click OK, and I can see stuff now. I'll turn my image back on here. You can toggle it on and off. The junctions aren't named what I want them to be named. It just sort of automatically names them based on where you click. And so you can rename them by going into the flex table for the junctions. And then I'm going to rename them as shown on the page here. What it's calling junction 1, I want to label that as bracket A bracket. So go through and do that process of renaming the junctions.
Is there a way you can blow up the labels? I think that's the C.
Yeah, that's what we just did.
Oh, sorry, I missed that. Go to Tools, Options. And then Units. No, sorry, Drawing. And change both of those to 9.
Just one second. Let me finish these labels and I'll be right over.
How do we import the image? I gotta say to my right goes on. The browser.
Toggle the drawing on and off with, I can't believe, this button right here. There you go. Let me pause the recording. So again, if you are having trouble seeing the symbols because they're too small, you go to Tools, Options, Drawing, and then you can change the symbol size multiplier. I'm going to go all the way up to 10. I'm feeling it. So now my symbols are that much larger. And if I don't like the fact that they're kind of on top of things, I can go and change them just by, dragging them to the side a little bit. Oops. I can drag the annotation out of the way if that's what I prefer. Okay, so go into the flex table for the junction and enter elevation now, because you wrote down all the elevation data. Tools, Options, Drawing to change the annotation size. So annotation size, Tools, Options, Drawing, and then change the symbol size multiplier. That's officially the last time I'm going to say it.
How did you do that? You just clicked on the journal?
Yeah. Yeah, you have to be careful not to get the underlying pipe or something. You go into the flex table. So, yeah.
And then the junction. And then that's where you change the label and the elevation.
All right, so if you haven't already, putting in the junction, elevations, and labels. So let's see here, 204. And also open up the reservoir flex table and you can put in the reservoir elevation. If your symbols are still too small because you're working on a small screen, maybe these tablets, the screen's too small, boost it up to 15 something. Make it as big as you need it to be able to see. Okay, you can also change the pipe names, just like we changed the junction names. You can go into the pipe table and change the pipe name so that, see, it says the start node and the stop node, so I'm going to call that pipe AB. If I enter pipe BC. And I also need to put in the pipe sizes. It, by default, assumes 152 millimeters is the pipe size. But on the page here, we actually know what the pipe sizes are. And so I'm going to go into the flex table and bring that up to date. Pipe sizes.
Is it supposed to go in evaluation mode? Or do you have to activate it, I guess? Because it said it was 0 to 0.
We try to run it doing your own. Said it was things.
It'll run in evaluation mode, so. I think it will. I'll show you the parts.
So you have your work, but they haven't. You just said that I was like, super attribute and run the next item.
Yeah, but we tried to say, the thing also said it is more than
They said they give you the.
You just select it with the that symbol. So what we're defining are the junction elevations and the pipe sizes. The labeling is for our convenience. It doesn't have to be labeled a certain way for it to execute the hydraulic model. But you do have to have elevations and pipe diameters or else it won't execute the hydraulic model. Also, what we need to do is define flow demands. And so let me show you or remind you, we've seen flow demands before. You go into the junction, and then it's this demand collection is where we're going to define the demands. And so I've got a demand at B. I click on the little dot, dot, dot over here, and then I'm going to say that I've got 25 liters per second demand at B. At F, I've got that 50. And then it was at junction A where I have half of the interior flow. So that was 86. And then the last one was at junction E, another 86. At this point, save your work. Just save to make sure that you don't lose it. Doesn't matter where. Friday. Everybody seeing how to enter the demand? Have you guys entered demands yet? I can't get it. That's fine. We're going to have to probably change to get a serial. Okay, get ready, because I'm going to put it on screen. You're going to have to type it, all right? Or I could email it to you. Do you still have your email up?
Yeah.
Even if you don't have your demands entered yet, I want to make sure if any of the rest of you have an expired license on the computer that you're using. And so click on the green compute arrow, and if you don't have a valid license, it's going to give you some sort of an error. What does that error say, Jonathan? It was just something about a license, you know? All right. So how many, raise your hand if you got that error message. So does this machine or anybody else have that error message come up when you click on the green compute? Has everyone clicked on the green compute? Nobody else got the error message? All right, Jonathan, you guys, you got it too? All right. So do you still have your email open? I'll email you the key that you need to paste in. So just 1 minute. All right, since we're running low on time, let me show you the idea here. Once you've defined the elevation, the demands, and the pipe diameters, then you can execute the model, and if you go into the junction table, for example, it will tell you what the pressure is at each junction. Well, that's nice to have it in the junction table, but it's more convenient if it's annotated on the map itself, so I'm going to have a new annotation. I'll have it be from the pressure. And so I'll put in the prefix here, pressure equals, I'll specify I want it offset a little bit, so it's not exactly There we go. So now I know the pressures. I'd maybe adjust the location of these so it's not on top of things. But what you can do is in the analysis, it asks, what is the pressure at each junction? And there it is. I've just solved it. So that analysis part is done. But in redesign, what I'm asking you to do is change the diameter of the pipe. If we go into the pipe network here, right now pipe AF is pretty big. That is a 250 millimeter diameter pipe. What if I made it 225? Is my pipe network still going to be acceptable? Like right now, I say that acceptable would be 300 kilopascals. So I've changed this one pipe, AF. I made it a little smaller. I re-execute the network. Pressures are slightly lower, but not that much slower, so it's like I got away with it. I saved money. I used a smaller pipe, and the pressures didn't change bad at all. So I can go into the pipe network a little bit more. I'm gonna make this 200. And in fact, I'm going to try this one being 150. So I will re-execute the model with these smaller pipes. It brought the pressure down a little. Now see, one of these, pipe E, is too low. It's down to 147. So it looks like I need to increase the size of these pipes a little bit, but still these pipes up top are too big because my pressure is much higher than it needs to be. That's the process of optimization. In the rest of this assignment and redesign, what I'd like you to do is go through and find out what's the smallest possible pipe to the nearest 25 millimeters that still gives you an acceptable pressure of 300 kilopascals everywhere in the network. To annotate, if I wanted to do, for example, if I want to do the flow rates through the pipes, whichever one you want to annotate, if it was pipes or junctions, you right-click on it, New, Annotation, and then you pick which field you want to annotate. Let's say I'd want to do flow, and then here in the prefix I'd have Q equals, pick an offset for the location, maybe -10, -10, apply, and there it is. So annotation, you right-click on the element that you want to annotate. Okay, so I've just showed you how you do the analysis and then also what the process is for redesign. Redesign or optimization is just going in there and looking at how the network is behaving and knowing that I could make this pipe AB smaller. It's larger than it needs to be. Why not try for 125? Re-execute the model. The pressures came down a little bit, so I'm getting closer to that limit of 300, but I can probably push it a little bit further, save the client some more money. Be sure and save your work, but starting from scratch, this won't take too long, and I'm going to post the recording on YouTube. I'll email a link out to everyone and also post the link on MU Online so that if you want to watch through this brief recording and see what the steps are, you've got them there available to you. And that'll give you fun things to do during Thanksgiving. Impress your relatives, show them that you're doing some technical software. WaterGEMS is installed on our lab computers, and if you want, you can also install it on your home PC. I'll send out the instructions on how to do that again. I sent out the instructions previously, but I'll send out another blast that has that so that if you want to install it on your own machine, you can do that. All right, so let's say that you don't have a jump drive today and you want to save your files. Let me show you what you have to do to email yourself the files. Because let's say I save mine, save, and I'm going to save it, save as, so I can change the location. Okay, I've got this folder, C-Temp Bentley. So I want it to be in C-Temp Bentley. So now if I go to Windows Explorer to C-Temp Bentley, it actually created several files. You need all of them to get it to work. And so, and one of them is really big, much larger than it needs to be. So click them all, highlight them all, right-click, send to compressed folder. And you'll notice it'll create an archive that has all of these in there, and it's very small, 347 kilobytes, and that includes this one file that was 8 megs. And so if you double-click on it, it'll show you what's inside there. So email yourself the zip file, and then when you want to use it again, unzip it. The way you unzip something is right-click on it, extract all, and it takes you through a little wizard and asks you, where do you want to extract it to? And then it will extract it to a folder, and there they all are, good as new. So that's what you want to do. I'll give you a couple of minutes to save your work and email it to yourself or put it on a jump drive, but if you did want to save your work, there you go. We'll meet back in this room at 2 o'clock for the exam.
Yeah.
All right?
Thank God.